At the end of my last video, I explained a little bit why graphing, our first method for solving a system, was good and like what it did well, and then I also mentioned kind of some shortcomings of it. Graphing is fine and it works and it makes sense, but sometimes you just don't want to graph it. It's just like, this is going to be really gross to graph, the numbers are too big. And if your answer isn't a whole number, graphing really isn't going to get you a precise answer. It'll just give you an estimate of where it's at. So we have to learn other methods for solving systems that kind of don't involve graphing. Today's method is called substitution, and it's going to be an alternative to solving by graphing. If I give you either of these problems or any sort of situation, there's nothing that says like there's only one right way to do it. You could get y by itself in each of these, graph them, see where they cross, and you'll get your answer. This is just it's an alternative method you can use. I went ahead and wrote the steps up here. Substitution, when you think about substituting something, you're plugging it in, you're replacing it. So we need to get a variable by itself and then plug it into the other equation. That's basically going to be our approach right here. So if you look at this first problem right here, my first equation says y equals 5x. That means that y and 5x are the same thing. Y, 5x, they're interchangeable because they're equal to each other. So anywhere in the problem I see a y, it's really a 5x. I can do that if I wanted. And anywhere I see a 5x in the problem, it's really the same thing as a y. So think about substitution in sports. If you're sending in a sub in a basketball game, you're sending in a new player to take the place of somebody else on the court. And I know right here that y is the same thing as 5x. So what I'm going to do, I have this y by itself. I'm going to send in 5x, the sub, for y in the other equation. Since y equals 5x, I can replace that y right there with the 5x, and my problem won't change at all. I'll still get the same answer. So I'm going to write down what happens when I do that. I get negative 3x plus 2, and then instead of writing times y, I'm going to write down times 5x. When you plug something in, which is what I did there, you put it in parentheses, and it still equals 14. Now you may say to yourself, after I do that right there, that actually looks more complicated than the original problem. It just looks kind of like a mess here. Why would I even want to do that? But if you just clean this up a little bit, you have your negative 3x. 2 times 5x is a positive 10x equals 14. This is an equation with just x's in it. There's no more y's in my problem, so I can solve that. You've known how to solve that for years. You combine like terms. You get 7x equals 14. And you divide both sides by 7, you end up with x equals 2. So we plugged in, so we only had one variable to worry about, and then we just solved the problem right there. We're not done with our answer. We got x, but we need to solve the system, which means we need x and y. So the part that confuses kids and gets them tripped up with systems, I think, it's always like, where do I plug that in, or what do I have to do next? Once you found x right here, x is equal to 2. Anywhere in this entire problem that you see an x, it's really a 2. That's what you found right here. X equals 2. So it doesn't matter if I plug in a 2 here, or here, or here, or here, or anywhere in the problem, I'm allowed to do that because x equals 2. But my job is to solve for y. I need to plug it in somewhere that has y's as well. That way I can actually figure out what it equals. You can plug it in either of the original equations and you will get y. So I can plug in a 2 right there, do a little bit of math and get y by itself. But it's actually easier to plug in the 2 right here. If you do that, you just get y equals 5 times 2, which is 10. So you got x equals 2 and y equals 10. Don't forget to write your answer as an ordered pair. The answer to this problem is 2, 10. I have one more problem in this video here. And it's just another example here. Again, you could graph this thing and it would work out fine. But let's try to use our new method of substitution. We have to get a variable by itself. And as luck would have it, in this problem, the x right here in the bottom equation is already by itself. That means this negative 8y minus 3 is my substitute. I can send that in for x in a problem and it won't change the answer. So I'm going to send that into the other equation. I'm sending in the sub in basketball game. So what's going to happen here is I'm going to have that guy go in for x in the equation. So instead of writing 5 times x, I'm going to write 5 times negative 8y minus 3. And then I have my plus 4y equals 30. Remember to put things you plug in parentheses. That whole guy has to go in parentheses there because we need to distribute our 5. So we get negative 40y minus 15 plus 4y equals 30. And then it's just doing a little bit of algebra here. You combine like terms, add 15 to both sides, kind of going through these steps fairly fast. We're going to divide both sides by negative 36 here, and I believe that's a negative 1.25. Yeah, that looks right. So I got y equals negative 1.25, which is totally fine. That answer isn't a whole number, but there's nothing that says every problem will have whole number answers. Remember though, I'm not done. I need to take this y, and I need to use it to get x. So I can plug it in either this equation or this equation, doesn't matter. I think it'll be a little easier to plug into the bottom equation since x is already by itself here. So all I have to do is x equals negative 8 times negative 1.25 minus 3. That's going to be a 10 minus 3, so I believe you get x equals 7 when you plug it in. So my final answer on this one is 7 comma negative 1.25. That's an answer that actually graphing probably wouldn't have got us that exact answer. We'd be close, but the decimal makes it tougher to do. But we get our exact answer with substitution.